Jesus, thank you very much. I don't really need to tell this audience of the importance of dementia. And could you put the right hand? There we are. Thank you. Of the importance, not only the human tragedy of dementia, but also the enormous economic cost, calculated as being equivalent to the gross national product of Turkey. So enormous. And that's not just the cost itself, it's the opportunity cost, it's the research that we can't do into other problems that we can't do to solve things like global warming, and the cost to our grandchildren in that economic burden. The political drive has been very valuable. The UK used its presidency of the G8 to create the Dementia Challenge and have a G8 Global Dementia Summit, and a number of countries since then have carried forward that initiative, and it is essential that we continue to do that. And the WHO sort of finished off earlier this year that first tranche of political activity with a ministerial conference in March. There was a declaration at that G8 summit, much of it I think fairly obvious of what one would aim at. Of course, it's important that we can't trade off care today for research tomorrow, but the very first bullet point is perhaps the key one, and that's the one that Zarvan Kachachurian spoke to. Can we be identifying a cure or a disease-modifying therapy? Now, it's interesting the term dementia was used there. Politicians tend to conflate dementia with Alzheimer's disease, but of course most of the focus at the moment is inevitably on Alzheimer's disease. And we haven't done very well. So this was a review of what was in the pipeline in 2010 in this nice review in the Lancet Neurology. All looks quite encouraging with that pipeline of drugs, but most of those that were going into phase 3 have since been killed off. Some of them are perhaps coming back as we change our view of when we do need to treat. But when you look at the drugs that are available for Alzheimer's disease, and I won't only be talking about Alzheimer's disease, it's over 10 years since anything has come onto the market. Now, Zarvan's already mentioned that much of this may relate to the fact that we are dealing with patients who fulfill the criteria for Alzheimer's disease, and although there's been a shift more recently to how we might define that entity, until relatively recently, it's required somebody also to fulfill the criteria for dementia, i.e. you are waiting until something is very severe. It's like waiting until a neoplasm has metastasized before you decide that you can make a diagnosis and start treatment. Doesn't quite feel right. And so this is, just to illustrate that, this is from ADNI data just showing that if you take individuals with established disease, then in terms of brain shrinkage and ventricular enlargement, you are dealing with a very far advanced and rapidly advancing disease state. So one can't really rely on doing your trials at that stage. And I think we do have a problem with this term dementia. It's politically very useful, but to wait until something is sufficiently severe is, I think, problematic. It's partly to do with how we interrelate with patients. It's partly to do with the conceptual difficulties we had with these diseases until relatively recently. Of course, dementia is only the tip of the iceberg, and underneath one assumes, early progressive disease and pre-manifest disease, be it Alzheimer's disease or Huntington's or vascular. And this term mild cognitive impairment, which is of course not a stable construct, it just describes something that's slightly less severe than dementia. And of course there are numerous causes for people having some impairment of their cognition. But that stage of pre-manifest Alzheimer's disease or early Alzheimer's disease has been around for a very long time, and particularly John Morris and colleagues and Price have provided suggestive evidence from cross-sectional post-mortem studies of individuals suggesting that quite a long time in elderly people before you may get the manifestations of significant cognitive impairment, one has variable degrees of the pathologies that we associate with plaques and tangles. So can we learn more about these pre-manifest stages of the disease? Can we understand this to move trials, as Zarvan suggested, into those earlier stages? The problem is that pre-manifest Alzheimer's disease, and I'm just illustrating this with Alzheimer's at the moment, pre-manifest Alzheimer cohorts are very difficult to come by. You can, of course, go for population-based, and scientifically these are very good because these are naturalistic populations, but you do have to examine a very large number of people in an aging cohort in order to pick up those relative number that will go on to develop a disease, and so you're limited by how detailed an assessment you can do. Mild symptoms, you're probably already well down the stage of the disease. You can enrich by age, you can enrich by genotype, but probably the most detailed information has been in those with autosomal dominant disease. For Alzheimer's disease, those who carry mutations either in the presenilin 1 or 2 genes or in the amyloid precursor protein, the APP gene. And the dominantly inherited Alzheimer network run from WashU has brought together a very large number of centers, predominantly in the US, who see individuals with those familial Alzheimer's disease genes, often coming on in their 30s, sometimes 40s and 50s, and have been able to infer from the cross-sectional data that there is indeed a long pre-manifest stage. And this is a summary taken from Randy Bateman's New England Journal of Medicine paper, suggesting this is rather very much a suggestion that the A-beta 142 may be high early on, but actually the drop in the CSF changes are really quite early. CSF tau and A-beta deposition, the latter being measured on PIB scanning, later hippocampal volumes and glucose metabolism, and then much later the clinical features. The A-beta deposition, I just show this slide because it is an example taken from Diane. Here's an individual who carries a mutation. These are the non-carrier individuals that, of course, provide extremely good controls because they've had early environmental exposures that are common, being brought up together, and they will share much of the genome apart from the specific mutations. Just one point of note, though, is the prominent striatal deposition using PIB scanning. I do just draw attention to that because we are making the assumption that you can generalize from familial Alzheimer's disease to the more common later onset Alzheimer's disease. One cannot assume that. Much may be generalizable, but these may be quite different diseases. And I think that the pattern in PIB suggests that something rather different may be going on. But from these data, the WashU group have suggested a sequence of events in the development of Alzheimer's disease in terms of the biomarkers, that you pick up changes in A-beta in the CSF first, and then you get the deposition of amyloid fibrils with PIB binding, increase in the tau and hippocampal volumes going down before you get the symptoms. This is an inference. This is, of course, an inference that's similar to the Braak and Braak inference, which are only cross-sectional data, and there are problems with assuming that that's going to be the sequence of events. And there is also a problem in that you estimate when you think symptoms are going to come on by comparison with the parents, comparison with other family members. And of course, diagnostic approaches, people's perception of disease changes. So it's likely that if you're looking at cross-sectional data, you will assume or infer that there are changes earlier than they really are. And in order to get some sense of what happens in the real world, rather than inferring from cross-sectional data, you do need to follow individuals for a long period of time. Now, that's very expensive, very difficult. So I just illustrate a couple of examples of individuals because I think it helps. So this is somebody with a pre-senilin-1 mutation, and these are volumetric T1 scans taken over a period of 6 years. And at time 0, the individual was entirely well. If you, however, register the scans to the baseline, you can see the ventricles are actually rather larger here 6 years later. You can see that there has been shrinkage. This is the point where they began to develop symptoms. And this just shows this in a little bit more detail. So this is the brain volume. This is symptom onset. This is actually when the person fulfilled the original NIHR criteria for Alzheimer's disease. Sadly, this person who developed the disease at 36 subsequently came to post-mortem and had typical Alzheimer histopathology. These are fluid registrations against baseline, where red indicates expansion, so the ventricles are expanding, and the green and blue indicates shrinkage and atrophy, which, as you can see, are here in the medial temporal lobe and then into the association cortices. And just looking at that at a group level, now just going to show you are a relatively small number of individuals like that, where one's actually looking at where the rate of change differs, because it's the rate of change that one's interested in. And if one looks at pre-symptomatic mutation carriers, you can see that in fact there are changes here in the medial temporal lobes and in the association cortex in the cingulate area. This is rate of change. So this is where the rate of change differs from the rate of change that might occur with aging in the mutation-negative cases. More extensive when you look at the mildly affected, and when you get to the stage where you actually have established disease. In fact, interestingly, it's more extensive, but you lose that significant signal in the medial temporal lobes. Remember, this is atrophy, so it may just be there's a lot of variance, so you don't see a statistical significant difference, but it may actually be that once the disease has progressed a certain stage, in a sense it's burnt out in the hippocampus, and you haven't got a lot more to lose in that area, so you won't see a signal when you're looking at the rate of change. This does look, though, rather like a Braque and Braque inferred map of the progression of the histopathology, and provides some assurance that at least in familial Alzheimer's disease, this is a prolonged pre-manifest stage of the disease, which should be the target for treatment. And there are now a number of trials have been started in this particular group. There's the trial in the Colombian pre-senilin-1 kindred. There is the dominant International Alzheimer Network trial, and then there's the A4, the asymptomatically elderly patients who have PET amyloid positivity, all with different immunotherapy approaches. The DIAN trial has an adaptive design, so based on biomarker change, and if there's no evidence of target engagement, then the drug is dropped and the next one becomes available. If there's evidence, then they'll move on to be looking for cognitive and behavioral changes. I do think this is going to be critically important. It may be that you won't be able to generalize from something that is able to treat familial Alzheimer's disease into the more common later onset disease. But at least once you've got something that may be effective, then you can start designing better trials, and you can begin to understand how to approach the disease, because you've got a gold standard, you've got something that you know will actually work. As Zarvan said, it's not all about Alzheimer's disease, lots of other causes of degenerative dementia, and much has been learned recently about the frontotemporal lobar degenerations, that intriguing group of diseases divided up to the behavioral variants, extremely difficult to manage in the clinic, and those with language and speech problems, and divided between those with a genuine language, a breakdown of their semantics, versus those with speech production difficulties. And it is very complex. I don't need to go into this in any detail, but other than that, here are the various phenotypes that one sees in the clinic, here the underlying molecular pathologies, but importantly, these three genes, C9orf72 expansions, granulin, the progranulin gene, and microtubule-associated protein tau, are the main contributors to familial frontotemporal dementia. And an autosomal dominant family history is probably found in about 15 to 20% of individuals. So this provides another opportunity to explore whether there is a pre-manifest stage and how one might best approach treatment. And to look at that, there's been a genetic Ftd initiative based in Europe, linked in with Canada, using EU money and local national money. It's run out of University College London, and the centres that are in capitals there are those that have joined the GenFi initiative just in the last year or two, and very good to have Barcelona and San Sebastian have now joined to contribute families with NERN, tau, granulin, or C9orf mutations. And one can make the same theoretical progression of biomarkers that one sees with Alzheimer's disease, the famous Jack curves. And yes, there is evidence that this applies to frontotemporal dementia as well. These, I would again emphasize, are only cross-sectional data, and therefore it is likely that they overestimate how early the disease begins, but this is just looking at cortical volumes against the anticipated age at onset here, and the insula appears to be common and early across these different diseases. There's a problem at the moment. These are only the first cut of data. These was published in Lancet Neurology earlier this year, in that because of the relatively small numbers, all of this group of diseases were in fact grouped together for these analyses, but there are now emerging some differences, in particular around tau and its early involvement of the medial temporal lobes. And I'll just show an example. Again, these individual examples are hard to come by, but they're very informative. So this is an individual with a tau mutation, and again, this is the fluid registration showing the striking symmetric anterior temporal lobe and hippocampal atrophy. And these are the hippocampal volumes of this individual against their sibling who did not carry the mutation. And you can see here that, in fact, changes are being picked up about 8 to 10 years before symptom onset. The advantage here, of course, is you're following people through until they actually develop the symptoms, so you know exactly what the natural history and the progression of the different biomarkers and the appearance of the behavioral changes are. And just to show you, we've been able to just begin to undertake PET imaging with the AV1451 tau ligand, and this is again a case of a tau mutation where the tau signal very much mimics those areas of atrophy that you saw in the anterior temporal lobe. Progranulin is very different, and I always like showing this video of registered volume MRI images because of the striking asymmetry that occurs with progranulin mutation positive FTD. I don't know the reason for it, whether it's something to do with some asymmetric insult because of the role of the granulin molecule. I'll just show you that, this is somebody who was imaged over a number of years and across the time that they actually developed symptoms. And if you see on the left there, or the right facing you, just how strikingly asymmetric and rapid the atrophy is in these progranulin cases. So yes, it does suggest that there is this very important pre-symptomatic stage in these dementing diseases, perhaps as long as 10 years, where we should be directing our attention in terms of the research. It's quite different from arguments about screening people as a public health measure. This is about where do you target trials of interventions. But I would like to finish by suggesting that we may need to broaden our view around what's beneath the dementia iceberg. Zarvan said there's many disorders other than Alzheimer's disease. And importantly, because we focus on dementia and its severity, there is an enormous amount of cognitive impairment that's beneath the waterline. And many, many things that we know will alter cognition. Medications, for example, general systemic ill health, stress, injury, pollution, poor education, and poverty. And that's only just a few exemplars. And all of these, of course, will impact upon the cognitive capital of a society, of a group, of a nation, or of an individual. And last month in the Lancet, Martin Knapp from the London School of Economics and I suggested in the Lancet that is it possible to adopt an idea from the other big global challenge we face, global warming, and actually model a cognitive footprint. And a cognitive footprint would either be at an individual level in terms of activities that people undertake, or would be at a group, a family, a group, societal, national level in terms of policies. And a cognitive footprint could either be positive in terms of benefit or negative in terms of a negative impact on cognition and cognitive capital. So that one can then return to some of these, and in thinking of ill health, it means that one can then begin to model sometimes those disorders that we forget about that are so important in developing countries like childhood malaria or neurocystic modest but measurable changes on cognition. And of course, negative cognitive footprint or negative impacts early in life will have a bigger cognitive footprint than those that may be emerging later in life. One can be aware of the problem of poor education and poverty. The introduction in the UK of raising the school leaving age in 1947 has impacted upon, it is believed, an effect on robust resistance to cognitive impairment in later life. Medications. We are very used to patients not taking medication because it makes them feel sleepy or not with it. And we tend to ignore these negative cognitive impacts of medication. Should we, in fact, be measuring a cognitive footprint of medication, a very simple real-world cognitive measure as part of the adverse event recording that then allows one to assess a cognitive footprint. But that's a suggestion, and I personally think we do need to broaden the debate for looking ahead and see if it is possible to model cognitive footprints. And I think this is also at an individual level rather than just at a larger society level. So at an individual level, I always like to end with one of the Rochefoucauld maxims. It's I'd like to die as young as possible, but as late as possible. I'll leave it there.